This topic is about finding the nth term of an arithmetic sequence and being able to solve problems involving arithmetic sequences and series. We need to be able to prove the formula for an arithmetic series and be able to identify when to use the formula. So first, let's start off with the definition of arithmetic sequences. So this is when the difference between any two consecutive terms is always the same. So this is called the common difference. So that means if A is equal to the first term, so this notation is using the Excel syllabus, and D is equal to the common difference, and N is equal to the term number, then the sequence is just rewrite that. The sequence is, first term would be A. The second term is, to get the second term, you do add D, so you get A add D. Then you add D again, so you get A plus 2D. Keep adding D. A plus 3D. So this is a U1. This is U2. This is U3. U4. And imagine if we go dot, 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 dot. Let's try to find out what UN would be. Then if you look at this, if the subscript is 2, if it's U2, then there's one less D. If it's U3, there's one less D at 2D. If it's U4, then it's one less D with 3D. So that means you're going to have an A, because there's an A in every single term. But then you're going to get 1 less than N, so N minus 1 times D. Okay, therefore, UN, which is the nth term, is equal to A plus N minus 1 times D. And if you want to write this recursively, or as a recurrence relation, it's the same thing as writing equivalent to, which is equivalent to this, which is UN plus 1. To get the next term, you're taking the previous term and adding D, where U1 is equal to the first term, which is A. Okay, so that's what an arithmetic sequence is, and this is given to you. UN is given to you in the formula booklet. So it's not given to you in the formula booklet, so you need to memorize this formula. Okay, so let's go through some questions. So how many terms are there in the sequence? There in the sequence 7, 11, 15, all the way up to 1, 4, 3. So I can see clearly that I'm adding 4 in each case. So in this case, A is equal to the first term, which is 7. And D, which is a common difference, is because I'm adding 4 each time, it's 4. Okay, so the formula is UN. UN is equal to A plus N minus 1 times D. Okay, what we do know is, obviously, we're trying to find out what term this is. So that means I know the nth term is 143. So the 143 is equal to A, which is 7, plus N minus 1 times 4. Okay, which means if I take away 7 from both sides, 143 take away 7 is 136, is equal to N minus 1 times 4. If I divide by 4, 136 divided by 4 gives me 34, is equal to N minus 1, which means N is equal to 35. Next question. An arithmetic sequence is 120, 114, all the way up to 36. How many terms are there in this sequence? Okay, again, A is the first term, which is equal to 120. we know the common difference is we're subtracting 6. So D is equal to minus 6. And we know UN is equal to 36. So the formula is UN is equal to A plus N minus 1 times D. So 36 is equal to 120 plus N minus 1 times minus 6. If I subtract 120 from both sides, 36 take away 120 is minus 84, is equal to N minus 1 times minus 6. If I divide by minus 6, so negative 84 divided by negative 6, it gives me 14. 14 is equal to N minus 1, which means N is equal to 15. So there are 15 terms in this sequence. Fourth term in an arithmetic sequence is 12 and the 20th term is 92. So that means U4 is equal to 12 and U20 is equal to 92. Now using UN is equal to A plus N minus 1 times D, that means U4 is A plus 3D. So that means U4, which is equal to A plus 3D, is equal to 12. And we get U20, which is equal to A plus 19D, is equal to 92. So we've got these two equations with two unknowns. A plus 3D is equal to 12, and A plus 19D is equal to 92. Equation 1, equation 2. So if I do 2 take away 1, I end up getting 16D is equal to 19D take away 3D. So the A's will get eliminated. 19D take away 3D is 16D. And 92 take away 12 is 80. Which means D is equal to 80 divided by 16, which is equal to 5. Okay, so D is equal to 5. Now that I know what D is equal to, so since D is equal to 5, I can use any of the equations to find out what A is. So A plus 3D is equal to 12 implies A plus 3 times 5 is equal to 12, which implies A plus 15 is equal to 12, which means A is equal to 12 take away 15, which is equal to negative 3. Okay, what is the formula for the nth term of this sequence? So UN is equal to A plus N minus 1 times D. So I've just worked out what obviously A and D are. So UN is equal to A, which is minus 3 plus N minus 1 times 5. If I want to simplify this, I end up getting is equal to minus 3 plus 5N minus 5, which gives me 5N take away 8. Therefore, UN is equal to 5N take away 8. Okay, next question. The first three terms of an arithmetic series are 4x take away 5, 3x, and x plus 13. So you've got this list. Let's just 4x take away 5, 3x, and x plus 13. X plus 13. This is U1, this is U2, and this is U3, which means this is A plus D, because we're adding D, and this is A plus, add D again to get A plus 2D. That means when we do U2 take away U1, we're going to get D, but also when we do U3 take away U2, we're going to get D, which means U2 minus U1 must be equal to U3 minus U2. So if I do 3x take away 4x take away 5, it must be equal to x plus 13 take away 3x. Now, if I simplify the left-hand side, I get negative x plus 5. And when I simplify the right-hand side, I get minus 2x plus 13. If I take the negative 2x to the side, I get minus x plus 2x. And then I get 13 take away 5 on the right hand side, which gives me x is equal to 8. Next question. The first three terms in an arithmetic sequence are minus 8, k squared, and 17k. So this is u1. Again, u1, u2, and u3. So this is, which is equal to a. You add d to get the next one, which is a plus 2 to a plus d. And you add d to get the third term, which is a plus 2d. So we can see that when we do u3 minus u2, we get d. And when we do u2 minus u1, we also get d. So that means u3 minus u2 must be equal to u2 minus u1, which is 17k minus k squared is equal to k squared minus 8, which gives me, 17k minus k squared is equal to k squared plus 8. If I take everything to the right hand side, I get k squared plus k squared, which is 2k squared, minus 17k plus 8 is equal to 0. If I factorize this, I get 2k, k, minus 8 here, minus 1 here, is equal to 0, which implies k is equal to a half, or k is equal to 8. An arithmetic sequence has first terms k squared and common difference k, where k is greater than 0. So that means the first term is k squared. If the common difference is k, the next term will be k squared plus k. Then we add k to this. So adding k each time. Then we add k to this. Then you end up getting k squared plus 2k, and so on. So you keep adding k. The fifth term of the sequence is 41. It's first, second, third. So the next one will be k squared plus 3k, and the fifth term will be k squared plus 4k, okay? So that means we have, find the value of k, giving you answer in the form p plus q root 5. So k is greater than 0, where p and q are integers to be found. So that means this is u1, u2, u3, u4, and u5. So we know u5 is equal to 41, which implies k squared plus 4k is equal to 41, which means k squared plus 4k minus 41 is equal to 0. K is equal to minus b plus or minus root of b squared minus 4ac all over 2a, where a is equal to 1, the coefficient of k squared, b is equal to 4, coefficient of k, and c is equal to negative 41, which is a constant at the end, which means k is equal to minus 4 plus or minus 4 squared minus 4 times 1 times negative 41 all over 2 times 1, which means k is equal to negative 4 plus or minus, if you put the thing underneath the side in your calculator, you get 180 all over 2. If I simplify it, it's the same thing as k is equal to negative 4 plus or minus 36 times 5 gives me 180. So it's going to be root 36 root 5, which is 6 root 5 all over 2, which means when you divide by 2, the integers at the top, I get minus 2 plus or minus 3 root 5. Now, as k is greater than 0, it must be minus 2 plus 3 root 5. Therefore, p is equal to minus 2 and q is equal to 3. Okay, so now I need to go to arithmetic series. So an arithmetic series is an arithmetic sequence in which all the terms are added together. So if it's S1, it will be just U1, which is just A. If it's S2, it's going to be U1 plus U2, which is just going to be A plus D. If it's S3, you're looking at U1 plus U2 plus U3, which is equal to A plus D plus A plus 2D, which is going to give you 3A. No, I'm not going to simplify actually, so that's what you're doing. And if I wanted to work out Sn, it will be equal to U1 plus U2 plus plus UN, which is equal to A plus D plus plus A plus N minus 1 times D. So that is what I mean by Sn, which is arithmetic, the sum of all the n terms, which is called an arithmetic series. Okay, so we need to find the formula for it. So let's find the formula for it, so we're going to do a proof to find the formula of the equation. So let me just write proof. So Sn will be the first term, which is A, plus the second term, which is A plus D, plus the third term, which is A plus 2D, plus all the way up to A plus N minus 2D plus A plus N minus 1 times D. Okay, now this is the first way you could write it. And we can also write it the other way around. So if you reverse it, so by reversing it, you get a similar equation, but the other way around. So instead of writing A first, write A at the end. So that one, this term, the previous term to A will be A plus D. The first term will be A plus N minus 1 times D. So when you reverse the order, this one will be A plus N minus 1 N minus 2D plus A plus N minus 3D. Okay, so this is equation 1 and equation 2. Now we know that you're doing the same thing. All you're doing is you're adding up all the terms in one way first, and then you're reversing the order and adding it together, which gives you the same answer. So if we do 1 add 2, then we get 2 lots of Sn is equal to, for the first, when you collect these two together, you're getting 2A plus N minus 1 times D. So you're going to get 2A plus N minus 1 times D. So when you add those two together, you get that. When you add these two together, you're still getting 2A. And because you got a D and then N minus 2 times D, you're still getting N minus 1 times D. So you end up getting, again, 2A plus N minus 1 times D. If you look at the next one, you see you still get 2A. And then again, you got N minus 3 lots of D, but then you got 2 more Ds. So you're going to get N minus 1 lots of D. So you get 2A plus N minus 1 times D plus blah, blah, blah. Let's look at the last terms. If you add this together, you see you're still getting 2A plus N minus 1 times D. And the last term, if you add these two together, you're still getting 2A plus N minus 1 times D. Okay, so what you do realize is you're getting N lots of these, so N times. Therefore, 2Sn is equal to N times 2A plus N minus 1 times D, because you're getting N lots of these. If we divide by 2, Sn will be N over 2 times 2A plus N minus 1 times D. And that is the formula for calculating the sum of n terms for an arithmetic series. Okay, that's one version. Now I can also write this term, so I can separate this out So I can write, if I go here, equivalent to, this is equivalent to, so equivalent to writing Sn is equal to n over 2. If I split up the 2a into a plus n minus 1 times d, then this is the first term, and this a plus n minus 1 times d is the last term. So it's the same thing as writing Sn is equal to n over 2, a plus the last term, let's call it L, where L is equal to the last term. So there's two different versions of the formula. You've got this version where you only know the first term and the common difference, and this one where you know the first term and the last term. The formula are given to you in an exam, so they're written in this. So to summarize, the sum of the first n terms of an arithmetic series is given by the formula Sn is equal to n over 2 times 2a plus n minus 1 times d. And you can also write this as n over 2 times a plus L, where L is the last term. Okay, let's go through some questions applying this formula. So find the sum of the first 50 terms of the arithmetic series 32 plus 27 plus 22, so on. Okay, so I can clearly see here from here, a is equal to, a is the first term, which is 32. If you look at this, you're subtracting 5, so the common difference is minus 5. N is equal to the 50 because it's the first 50 terms. Then Sn is equal to n over 2, 2a plus n minus 1 times d, which means S50 is equal to 50 over 2, 2 times 32, plus n minus 1 is 50 take away 1 times d, which is negative 5. If you put this into your calculator, you get negative 4,525. Okay, next question. Find the least number of terms required for the sum of 4 plus 9 plus 14 plus 19 to exceed 2,000. So in this, we know the first term is 4. The common difference is 5. N is what we're trying to find out, because we don't know how many terms there are. And we know Sn has to be greater than, the sum of all the n terms has to be greater than 2,000. So we know the sum of n, so Sn is equal to n over 2, 2a plus n minus 1 times d. So we know Sn, which is 2,000. So when we substitute our values in, this has to be greater than 2,000, yeah? So it has to be greater than n over 2, because we don't know what n is. 2 times a, which is 4, plus n minus 1, because we don't know what n is, times difference, which is 5. So this is the inequality we have to set up. So what I end up getting is, 2,000 is less than n over 2, we get 8 plus 5n minus 5 here. If we times by 2 both sides, we get 4,000 is less than n. 8 take away 5 gives you 3, so it's 5n plus 3. Now if I expand the bracket, I get 4,000 is less than 5n squared plus 3n. If I take everything to the right hand side, I get 5n squared. 5n squared plus 3n take away 4,000 is greater than 0. So I have to solve the equation first. So if I've got a is equal to 5, b is equal to 3, c is equal to negative 4,000. So using n is equal to minus b plus or minus root of b squared minus 4ac over 2a. Then n is equal to minus 3 plus or minus 3 squared minus 4 times 5 times negative 4,000 all over 2 times 5. which gives me two n values. N is 27.99 and n is equal to minus 28.59 using my calculator. Now if I sketch this inequality, I've got two roots, which is 27.99 and negative 28.59. Okay, and it's a positive n squared graph, so it looks like so. I need a part that's greater than 0, so I need this or this. Now n has to be positive because number of terms always has to be greater than 0. So as n is greater than 0, n must be greater than 27.99. But if n is greater than 27.99, n must be equal to 28. So the least number has to be 28. Find the sum of the following series: minus 6f plus minus f plus 4f plus 9f plus 14f and so on. So in this case, I know a, which is equal to minus 6f. I know the common difference is, because I'm adding 5f each time, the common difference is 5f. But I also know one extra thing, which is the last term, which is 59f. So what I can do is, instead of using the Sn formula with n over 2, 2a plus n minus 1 times d, I can use Sn is equal to n over 2 a plus l. Okay, but the first thing I need to do is find out what n is, yeah? To find out what n is, I need to use the un formula. So if I want to find out what n is, I need to use a un formula. So un is equal to a plus n minus 1 times d. So un is 59f. So 59f is equal to a, which is minus 6f, plus n minus 1, which is we don't know what n is, because we're trying to figure out what n is, times d, which is 5f. If we rearrange it, 59f add 6f gives us 65f is equal to n minus 1 times 5f. If I divide by 5f, I get 13 is equal to n minus 1, which means n is equal to 14. So we know there's 14 terms there. So using n equals 14, a equals negative 6f, and l is equal to 59f, s of 14 will be equal to 14 over 2 times minus 6f plus 59f, which is the same thing as 7 times minus 6f plus 59f is 53f, which gives you a value of 371f. Okay, let's go through some worded problems now. So the training program of a pilot requires him to fly circuits of an airfield. Each day he flies 3 more circuits than the day before. So I know d is equal to 3 in this case. On the 5th day, he flew 14 circuits. So I know U5, sorry. U5 is equal to 14. Okay, so let's do A. Calculate how many circuits he flew on the first day. So if the U5 is equal to 14, then that means A plus 4D is equal to 14, which means A plus 4 times 3 is equal to 14, which means A plus 12 is equal to 14, which means A is equal to 14, take away 12, which is equal to 2. Okay, B, in total by the end of the 5th day. So I'm trying to work out, in total it means S5, so I'm trying to find S5. S5 is equal to 5 over 2, or let me just write the formula down for it. Using Sn is equal to n over 2, 2 times a plus n minus 1 times d, where n is equal to 5, a is equal to 2, d is equal to 3. Then that means we get S of 5 is equal to 5 over 2, 2 times 2 plus 4 times 3, which is the same thing as 2.5 times 4 plus 12 is 16, which is equal to 40. That's B. C, in total by the end of the nth day. If it's nth day, then I have Sn is equal to n over 2, because we don't know what n is. Then we get 2 times 2 plus n minus 1 times d, which is 3. Now all I need to do is simplify this. N over 2 times 4 plus 3n take away 3, which is equal to n over 2 times 3n plus 1. So I'll leave it like that. D in total from the end of the nth day to the end of the 2nth day. So that's the same thing. Simplify your answer. It's the same thing as saying you calculate sum of the 2nth term and then take away the sum of the nth term. That's all you're doing. Now when it's 2n, you're substituting 2n into the formula, so you get 2n over 2, 2 times 2 plus 2n minus 1 times the difference, which is 3. Okay, and when we work out Sn, we've already worked it out, it's just n over 2 from part C, n over 2 times 3n plus 1. Okay, when we simplify, the first initial 2n divided by 2 is just n. You get 4 minus 3, which is 1, and 2n times 3 is 6, so you get 6n plus 1. Take away n over 2 times 3n plus 1. Now, we need to factorize this. So if we put this 1 over 2, then we have to write 2n over 2. Then we can factorize out the n over 2. So when we factorize the n over 2, we get 2 times, because there's a 2 at the top still, 2 times 6n plus 1. Take away 3n plus 1. Now, if we simplify this, we'll have to do it here. You get n over 2. 2 times 6n is 12n. 12n take away 3n is 9n. And then plus 2 take away 1 gives you plus 1. So that would be the answer. N over 2 times 9n plus 1. Okay, next question. The sum of the first 4 terms of an arithmetic series is 96. So that means S4 is equal to 96. The sum of the 5th, 6th, and 7th term is 219. So that means U5 plus U6 plus U7 is equal to 219. Find the first term and the common difference. Okay, so we need to write everything in terms of A and D. So S4 is the same thing as U1 plus U2 plus U3 plus U4 is equal to 96, which is the same thing as A plus D plus A plus 2D plus A plus 3D is equal to 96. So if we collect all these to get things together, I get 4A plus D plus 2D plus 3D gives me 60 is equal to 96. So that's my first equation. If I look at my second equation, which is, let me just rewrite it a bit on this side, which is U5 plus U6 plus U7 is equal to 219, then that means A plus 4D plus A plus 5D plus A plus 6D is equal to 219, which means 3A plus 15D is equal to 219. So I get 3A plus 15D is equal to 219. Okay, so this is equation 1. Equation 1 and equation 2. I need to make the A the same. So I need to times this one by 3, times this one by 4, which means I get 12A plus 18D is equal to 288. And the second equation is 12A plus 60D is equal to 876. So let's call this 3 and let's call this 4. Then if I do 4 take away 3, the A's will cancel out and I'll get 42D. 60D take away 18D is 42D. 876 take away 288 is 588, which means D will be 588 divided by 42, which is D is equal to 14. So if I know D is equal to 14, then using 4A plus 6D is equal to 96 implies 4A plus 6 times 14 is equal to 96, which implies 4A plus 84 is equal to 96, which implies 4A is equal to 96 take away 84 is 12, which means A is equal to 12 divided by 4, which is 3. B, find and simplify an expression in terms of n for the sum of the first n terms of the series. So that means Sn is equal to n over 2, 2a plus n minus 1, n minus 1 times d, which means Sn is equal to n over 2, 2 times a is 2 times 3, plus n minus 1 times d, which is 14. If we simplify this, I get n over 2. 2 times 3 is 6. 6 take away 14 is equal to minus 8. And then I get 14n. So I got 14n take away 8. Now I can divide the 14 and the 8 by 2. So I end up getting n times 7n, because if it's divided by 2, I can take it out by dividing the inside the bracket by 2. So 7n take away 4. Now we can leave it like that, or we could expand it, which means I get 7n squared take away 4n. Therefore, Sn is equal to 7n squared take away 4n. Next question, state the formula for the sum Sn of the first n terms of an arithmetic series with first term a and the common difference d. That is just stating the formula. Part B, prove that for any arithmetic series, S8 is equal to 2 times S6 take away S2. So let's start off with S8. So S8 is the same thing as 8 over 2 times 2a plus 8 minus 1 times d. Which is equal to 4 times 2a plus 7d, which is equal to 8a plus 28d. I'm working out S6. Similarly, I get 6 over 2, 2a plus n minus 1, which is 6 minus 1 times d, which is going to give me 3 times 2a plus 5d, which is 6a plus 15d. S2 similarly will be 2 over 2, 2a plus 2 minus 1 times d, which is 1 times 2a plus d, which is equal to 2a plus d. If I combine these together and I do S6 take away S2, then I get 4a plus 14d. And if I times by 2, then I get 2 lots of S6 take away S2 is equal to 8a plus 28d. Therefore, because I've got the same thing here, 8a plus 28d, 8a plus 28d, therefore S8 must be equal to 2 lots of S6 take away S2. Part C. An arithmetic series has first term 40, so a is equal to 40, and common difference is equal to negative 3. Find the sum of the positive terms of the series. So first thing I need to know is when is un, when does, which term is it less than 0? So when is un less than 0? So that means a plus n minus 1 times d is less than 0, which is 40 plus n minus 1 times minus 3 less than 0, which means n minus 1 times minus 3 is less than negative 40, If I divide by -3, remember the inequality flips over. So because minus 40 divided by -3 is 13.33 recurring, which means n is greater than, if I add 1, 14.3 recurring. If it's greater than 14.3, the first time n is negative is when n is equal to 15. So when n is equal to 15, n equals 15 when the nth term is negative. So that means I want to calculate s of 14 because I don't want to include the negative number. So all I'm doing is working out s of 14. Okay, which means 14 over 2, 2 times 40 plus 14 minus 1 is 13 times -3, which is the same thing as 70 times 80, take away 39. If I put that into my calculator, I end up getting 287. Okay, a publisher that decides to start producing calendars. A publisher sells 2,400 calendars during the first year of the production and forecasts that the number it will sell in subsequent years will increase by 250. So if I'm doing this question, I know my A is equal to 2,400 and my D is equal to 250. According to this forecast, find how many calendars the publisher will sell during the 6th year of production. Now, be very careful. This is the 6th year only, so it's U6 we're trying to find out. So UN is equal to A plus N minus 1 times D, which means U6 is equal to A, which is 2,400, plus N minus 1 is 6 minus 1 times D, which is 250. If you put that into your calculator, you get 3650. That's A, part 1. Part 2, show that this publisher will sell a total of 35,250 calendars during the first 10 years of the production. Now, because during the first 10 years, this is a series that we're working out. So that means we're working out, so the formula is Sn n over 2, 2a plus n minus 1 times d, which means we're working out S of 10. So 10 over 2, 2 times a, which is 2,400, plus n minus 1 is 10 minus 1, which is 9, times d, which is 250. If you put this into your calculator, you end up getting the number that you require, which is 35250. Part B, if the number of calendars sold in a subsequent year increases by C each year, so this is the common difference now, instead of by 250, find to the nearest unit the value of C such that the publisher would sell a total of 40,000 calendars during the first 10 years of production. So now we're trying to find out when the sum of the n terms is equal to 40,000. Okay, where A is equal to 2,400 still. Your common difference is C and your n is 10. Okay, so Sn is equal to n over 2, 2a plus n minus 1 times d. So that means S of n is 40,000 is equal to n over 2. So it's 10 over 2. 2 times a is 2 times 2,400. Plus n minus 1 is 10 minus 1, which is 9, times the common difference, which is c. Okay, so you end up being 40,000 is equal to 5 times 4,800 plus 9c. If I divide by 5, I get 8,000 is equal to 4,800 plus 9c. If I take away 4,800, 8,000 take away 4,800 gives me 3,200 is equal to 9c. If I divide by 9, I get c is equal to 355.555 recurring. And because c has to be to the nearest unit, the value has to be 356. Therefore, C is equal to 356. Next question. Ahmed begins making annual payments into a savings scheme. He pays £500 in the first year, and the amount he pays in increases by £40 in each subsequent year. So for part A, we know A is equal to 500 and D is equal to 40. Find the amount that Ahmed pays into the scheme in the 8th year. Because it's just the 8th year, it's U8. So un is equal to a plus n minus 1 times d. So u8 is equal to 500 plus 8 minus 1 times 40, which is equal to 780. Okay, pounds. Part B. Show that during the first n years, Ahmed pays in a total amount of 20n times n plus 4. So we're working at Sn. So Sn is equal to n over 2a plus n minus 1 times d, which is equal to n over 2 2 times 500 plus n minus 1 times 40, which is equal to n over 2 times 500 is 1000. Take away 40 gives you 960, and we've got 40n as well. Okay, we can divide by 2 everything in the bracket, so we get rid of the over 2. 960 divided by 2 is 480. 40n divided by 2 is 20n. We can take the 20 out as well, so we get 20n times 24 plus n, which is the same thing as 20n times n plus 24, which is what we wanted. Carol starts making payments into a similar scheme at the same time as Ahmed. She pays in £400 in the first year, with the amount increasing by 60 in each year. So that means A is equal to 400 and D is equal to 60. By forming and solving a suitable equation, find the number of years of paying into the schemes after which Carol and Ahmed would have paid in the same amount in total. So I need to find the formula for Sn for Carol. So Sn is equal to n over 2. For this one, it will be 2 times 400 plus n minus 1 times 60. If I simplify, I get n over 2. 800 take away 60 is equal to 740 plus 60n. If I divide by 2, I get n is equal to 370 plus 30n. And I can factorize a 10 out, so I get 10n is equal to 37 plus 3n, which can be written as 10n is equal to 3n. So 10n times 3n plus 37. Now, because we want them to be equal, then I need to equate the two equations. So we've got equation 1 and equation 2. We need to equate them. So that means I get 10n times 3n plus 37 must be equal to 20n times n plus 24. Because n is not allowed to be 0, so we can cross, I can cross it out. And we can divide by 10, so all we're left with is 2 here. So then we get 3n plus 37 will be equal to 2 lots of n plus 2 lots of 24, which is 48. Which means n is equal to 48 take away 37, which is equal to... n is equal to 48 take away 37, which is 11. Okay, last question. Prove that the sum of the first n positive integers is given by half of n times n plus 1. Okay, so we know if it's positive integers, we have the sequence 1, 2, 3, blah, blah, blah. So in this case, a is equal to 1, and the common difference is 1. So Sn is equal to n over 2 times 2a plus n minus 1 times d becomes Sn is equal to n over 2 times 1 plus n minus 1 times 1, which is equal to n over 2. 2 take away 1 is 1, and you've got n there, so it becomes 2 plus n take away 1, which is equal to n over 2 times n. 2 take away 1 gives you positive 1. So that is it. Okay, B. Hence, find the sum of the integers from 100 to 200 inclusive. Inclusive means I need to include 100. So 100, 101, all the way up to 200. So what I need to calculate is S of 200. Because I need to include 100, I need to take away S of 99. Because we're going to, if S of 200, we count all the way from 1 to 200, but we don't want the 1 to 99, so we need to take that off. Okay, so S of 200 take away S of 99. So S of 200 is just using the formula from part A, is 200 over 2 times 200 plus 1, and S of 99 will be 99 over 2 times 99 plus 1. We put this into our calculator, we get the value 15150. Okay, C. Oh, sorry, this is B part 1. B part 2. The integers between 300 to 600 inclusive which are divisible by 3. So that means we have the first term 300, 303, all the way up to 600. Okay, so that means I need to know which term this is. So this is un. So un is equal to a plus n minus 1 times d. So 600 is equal to a, in this case is 300, plus n minus 1 times d, which is 3. So that means 300 must be equal to n minus 1 times 3, which means 100 must be equal to n minus 1, which means n must be equal to 101. So all I want to work out S of the sum, S of 101 will be 101 divided by 2, 2 times 300 plus n minus 1, which is 101 minus 1 times the difference, which is 3. If you put this into your calculator, you get 45,400. Sorry, that's a mistake. 45,450. Okay. Oh, there was an easy way to do this question. Because it's 100 to 200 inclusive, and then it's 300 to 600 inclusive, what you realize is you can time these numbers by 3 to get these the number 300 and 600. So what you can do in part 2 is take your answer from the first part, which is 15150, and times it by 3. And it would, because the total would be 3 times bigger, so it would give you 45,450, which might be an easy way to do it. But if you can't see it that way, it's easier to do it the long way. You still get the right answer.